This documentary is designed for long listening. You can relax, listen closely, or allow it to play quietly in the background. Throughout history, civilizations have searched for patterns, signs that the world moves in cycles rather than straight lines. One of the most debated ideas connected to these cycles is the concept of a planetary reset. At the center of this discussion is Earth's magnetic field. The magnetic field is an invisible force that surrounds our planet. It shields Earth from solar radiation, guides navigation, and plays a vital role in protecting life itself. Scientific evidence shows that Earth's magnetic poles are not fixed. They drift, weaken, and over long periods of time, they reverse. This phenomenon is known as a geomagnetic pole reversal. Rock formations across the planet preserve records of these reversals. As molten rock cools, magnetic minerals align with the Earth's field, locking a snapshot of polarity in time. These geological records show that pole reversals have happened many times throughout Earth's history. Some occurred gradually over thousands of years. Others appear to have happened more rapidly. This raises important questions. If Earth's magnetic field weakens during a reversal, what effects might that have on technology, climate systems, and biological life? Scientists continue to study these processes carefully. While there is no evidence of an imminent catastrophic flip, the ongoing movement of the magnetic poles remains an active area of research. Beyond science, human belief systems have also attempted to understand cycles of destruction and renewal. Ancient religious texts, myths, and oral traditions often describe ages ending and beginning again. Some interpret these stories symbolically. Others view them as reflections of natural cycles humanity once witnessed but could not scientifically explain. In modern times, another observation has drawn attention. Public reports show an increase in the construction of private underground shelters, bunkers, and self-sustaining facilities, particularly among wealthy individuals and corporations. While these developments are often explained as preparations for economic instability, natural disasters, or geopolitical uncertainty, they raise broader questions about how societies prepare for the unknown. Is this simply risk management, or is it part of a deeper awareness of planetary cycles? In this documentary, we explore these ideas carefully, without assumptions. We examine science, belief, and observable trends, not to declare certainty, but to ask thoughtful questions. As this journey continues, consider how humanity has always tried to understand change, and how preparation often reflects uncertainty rather than knowledge. This is the beginning of the exploration. Earth's magnetic field is generated deep within the planet. Beneath the surface, molten iron moves slowly within the outer core. As this electrically charged material circulates, it creates a vast magnetic shield that extends far into space. This shield is not perfectly stable. It stretches, weakens, strengthens, and shifts over time. The magnetic north and south poles are not fixed points. They wander gradually, sometimes accelerating, sometimes slowing. Scientific measurements show that the magnetic North Pole has been drifting faster in recent decades, moving across the Arctic at an unusual pace. This movement does not automatically signal an imminent reversal, but it does highlight how dynamic the system truly is. Geomagnetic reversals occur when the magnetic field weakens significantly and reorganizes itself, eventually flipping polarity. During these periods, the field does not simply shut off. Instead, it becomes complex, forming multiple poles, fragmented regions of magnetism, and unstable patterns before settling into a new orientation. Geological evidence suggests that these transitions can last thousands of years. In some cases, the field strength drops to a fraction of its normal intensity. This weakening may allow higher levels of cosmic radiation to reach the planet's surface, affecting atmospheric chemistry and technological systems. Satellites, power grids, navigation systems, and communication networks are all influenced by magnetic stability. Modern civilization relies heavily on systems that did not exist during previous reversals. This raises an important question. How resilient is modern society to prolonged magnetic instability? Scientists do not predict sudden planetary catastrophe from a pole shift alone. However, they acknowledge that a weakened magnetic field could introduce challenges that humanity has never faced at a global technological scale. Long before modern science, ancient cultures recorded stories of cycles, ages of collapse followed by renewal. These narratives appear across continents and civilizations. Some describe great floods, others speak of fire from the sky, darkness, or long winters. Whether symbolic or literal, these stories reflect humanity's long-standing awareness that the world changes in dramatic ways. In religious traditions, these cycles are often framed as tests, judgments, or resets. In scientific terms, they may reflect environmental shifts, climate disruptions, or cosmic events recorded through cultural memory. Modern researchers approach these ideas cautiously. Correlation does not equal causation, yet the persistence of cyclical narratives across time invites reflection. Are these stories simply metaphor, or echoes of real transitions humanity once survived? As we examine Earth's magnetic behavior, we are reminded that the planet operates on timescales far longer than a human lifespan. Change is not an anomaly. It is the default state of nature. Understanding that truth allows us to replace fear with curiosity and speculation with study. This exploration continues. As Earth's magnetic field changes, it does not act alone. It exists within a larger cosmic environment shaped by solar activity, radiation, and the constant movement of energy through space. The Sun regularly releases bursts of charged particles known as solar storms. When Earth's magnetic field is strong, these particles are largely deflected, forming auroras near the poles and protecting the planet's surface. When the field weakens, more of this energy can penetrate the atmosphere. Scientists study these interactions carefully, particularly during periods of magnetic instability. Increased radiation exposure does not automatically translate into catastrophe, but it can place stress on systems that modern life depends on. Satellites may experience interference. Power grids can become more vulnerable. Navigation systems that rely on magnetic alignment may require adjustment. These are not hypothetical concerns. They are known effects observed during strong solar events, even under normal magnetic conditions. A prolonged weakening of the magnetic field could amplify these challenges. This is why Earth's magnetic behavior is monitored continuously. Beyond technology, there is growing interest in how environmental stressors influence biological systems. Some studies suggest correlations between geomagnetic fluctuations and changes in animal migration patterns. Birds, sea turtles, and other species are known to use Earth's magnetic field for navigation. Disruptions could require adaptation over time. Human biology is far less sensitive to magnetic fields, yet humanity's dependence on technology introduces new vulnerabilities. This intersection between natural systems and artificial infrastructure defines the modern era. It also raises broader questions about preparedness. Throughout history, societies that survived periods of change were often those that adapted rather than resisted. Preparation does not always imply knowledge of what will occur. More often, It reflects an understanding that uncertainty itself is a constant. In recent decades, public records and reporting have documented increased investment in resilience. These include hardened infrastructure, decentralized energy systems, underground facilities, and self-sustaining designs. Such developments are frequently explained as responses to climate change, economic instability, or geopolitical risk. Each of these explanations stands on its own. At the same time, they reflect a shared recognition that global systems are interconnected and fragile. A disruption in one domain can ripple across many others. This is not evidence of secret knowledge. It is evidence of risk awareness. The difference is subtle, but important. Speculation thrives where information is incomplete. Understanding grows where observation and evidence are prioritized. In this documentary, we do not assume intent. We observe patterns. We examine trends. We ask why resilience has become a dominant theme of the modern age. Earth has undergone countless transformations, long before human civilization emerged. Life adapted. Systems reorganized. New equilibria formed. The magnetic field is one part of that ongoing story. By studying it, humanity gains insight not only into the planet, but into its own relationship with change. This exploration continues. Across human history, change has rarely been viewed as random. Many ancient cultures believed the world moved in repeating cycles, periods of growth, stability, collapse, and renewal. These ideas appear independently across civilizations separated by vast distances and time. In some traditions, these cycles are described as ages. In others, they are marked by great floods, fires, darkness, or long winters. While the language differs, the underlying message remains consistent. Civilizations rise, they reach complexity, they destabilize, and something new emerges from the aftermath. Modern science does not interpret these stories literally, yet it recognizes that environmental pressures have shaped human history in profound ways. Climate shifts, volcanic activity, solar variability, and geological change have all influenced migration, agriculture, and societal stability. From this perspective, the concept of a reset does not imply a single catastrophic event. It reflects a pattern of adaptation driven by environmental stress. Religious traditions often frame these cycles in moral or spiritual terms. Periods of imbalance are followed by correction. Disorder gives way to renewal. In scientific terms, these narratives may encode observations of change that early societies experienced but could not quantify. This does not diminish their value. It highlights humanity's long effort to understand forces beyond its control. As societies advanced, written records replaced oral tradition. Chronicles began documenting collapses, plagues, famines, and sudden disruptions. Many of these events coincided with environmental shifts, now identifiable through ice cores, sediment layers, and geological data. Once again, the theme of cyclical change emerges. The planet changes. Life responds. Civilization adapts, or fails to. In the modern era, technological progress has altered humanity's relationship with risk. Systems are faster, interconnected, efficient, and more fragile. A disruption in energy, communication, or climate now affects billions simultaneously. This reality has revived interest in resilience, not because catastrophe is certain, but because vulnerability is visible. Preparation, in this context, is not prophecy. It is acknowledgement. Acknowledgement that stability is temporary, that complexity carries risk, and that adaptation has always been humanity's most reliable survival strategy. Understanding cycles does not require belief in inevitability. It requires awareness. Awareness that Earth operates on rhythms far older than civilization itself. As we continue, we examine how modern responses to uncertainty mirror ancient instincts: to observe, to prepare, and to endure. This exploration continues. In every era of uncertainty, those with resources respond first. This is not new. Throughout history, wealth has often translated into mobility, protection, and preparation. In the modern world, preparation takes different forms. Rather than fortified cities or distant migrations, it appears as infrastructure, resilience, redundancy. Public records, corporate disclosures, and industry reporting show increased investment in hardened facilities, underground construction, and self-sustaining systems. These include data centers buried beneath rock, energy-independent compounds, and private shelters designed to operate for extended periods without external support. Such developments are frequently explained through practical concerns: economic instability, climate volatility, geopolitical tension, supply chain fragility. Each explanation stands on its own. Together, they reflect a broader shift in thinking, a recognition that interconnected systems, while efficient, are vulnerable to disruption. This does not imply foreknowledge of a specific event. It reflects risk awareness. Modern civilization is built on assumptions of continuity. Electricity flows, data transfers instantly, food arrives on schedule. When any one of these systems falters, the consequences cascade. Those with access to capital tend to prepare for cascading failure rather than isolated incidents. Resilience is no longer about surviving a single disaster. It is about maintaining functionality during prolonged instability. This mindset mirrors ancient survival strategies. Communities once stored grain for lean years. They built settlements near reliable water sources. They adapted architecture to climate and terrain. Preparation was not fear-driven, it was practical. Today, preparation appears more abstract, embedded in technology and infrastructure rather than visible defenses. Yet the instinct remains unchanged. When uncertainty increases, resilience becomes valuable. Some observers interpret modern preparation as evidence of hidden knowledge. Others see it as a rational response to visible trends. The truth likely lies between these extremes. Preparation does not require certainty. It requires probability. And probability is shaped by observation. Environmental volatility, technological dependence, global interconnectedness. Each increases the cost of disruption. In this context, resilience is not an admission of impending collapse. It is an acknowledgement of complexity. Complex systems fail in complex ways. The lesson repeated across history is not that collapse is inevitable, but that adaptation determines outcome. As we continue, we explore how natural cycles, technological systems, and human behavior intersect, shaping both vulnerability and resilience in the modern age. This exploration continues. Modern civilization depends on invisible systems. Electricity flows through vast networks of transmission lines. Satellites orbit silently, enabling communication, navigation, and timing. Data moves through global cables and servers at the speed of light. These systems function smoothly because Earth's environment remains relatively stable. Magnetic stability plays a quiet but essential role. When Earth's magnetic field fluctuates, even briefly, technological systems can be affected. Solar storms interacting with the magnetosphere have already demonstrated this vulnerability. In past events, satellites have experienced temporary failures. Power grids have suffered blackouts. Navigation signals have degraded or required recalibration. These incidents occurred without a full magnetic reversal. They were the result of short-term disturbances. A prolonged period of magnetic instability would present a different challenge. Not sudden collapse, but sustained stress. Transformers exposed to geomagnetically induced currents can overheat. Satellite electronics may require additional shielding. Aviation routes near polar regions may need adjustment due to increased radiation exposure. None of these outcomes are speculative. They are known effects studied by engineers and space weather scientists. What changes during extended instability is scale and duration. Short disruptions can be managed. Long disruptions require adaptation. Infrastructure resilience is not solely a technical issue. It is an organizational one. Redundancy, decentralization, fail-safe design. These principles reduce vulnerability when systems are stressed. They also increase cost. As a result, resilience is often implemented unevenly. Critical systems are protected first. Secondary systems follow later. This pattern has repeated throughout history. Roads, water systems, communication networks. Each era reinforces the same lesson. When complexity increases, so does fragility. This does not imply that modern civilization is on the brink of failure. It suggests that stability must be actively maintained. Magnetic instability would not act in isolation. It would interact with climate variability, economic pressure, and geopolitical tension. Small disruptions, when combined, can produce disproportionate effects. This is why risk assessment increasingly focuses on cascading scenarios rather than single events. Understanding infrastructure risk is not about predicting collapse. It is about recognizing dependency. Modern life relies on systems most people never see. When those systems are stressed, awareness becomes essential. Adaptation does not require fear. It requires foresight. History shows that societies which anticipate stress tend to recover more quickly than those that deny vulnerability. As we continue, we examine how knowledge, perception, and response shape outcomes during periods of change. This exploration continues. When uncertainty increases, human perception changes. Information is filtered through emotion, memory, and belief. Periods of instability often give rise to competing narratives, some grounded in evidence, others shaped by fear or speculation. This pattern is not unique to the modern age. Throughout history, moments of environmental stress, social disruption, or technological change have produced similar responses. People seek meaning. They search for patterns. They attempt to explain complex systems through stories that feel coherent and emotionally satisfying. Fear simplifies complexity. It narrows focus. It encourages certainty where uncertainty exists. Narratives built on fear often spread quickly because they offer clarity, even when accuracy is limited. By contrast, evidence-based understanding moves slowly. It requires patience. It accepts ambiguity. Science, by design, resists definitive conclusions until sufficient data exists. This tension between narrative and evidence shapes public response to change. When systems feel fragile, speculation can feel more reassuring than uncertainty. A clear story, even an incomplete one, can feel safer than unanswered questions. Yet history shows that fear-driven narratives rarely improve outcomes. They amplify stress. They reduce cooperation. They encourage reactive decisions rather than adaptive ones. Understanding this dynamic is essential. Change itself is not the primary threat. Misinterpretation of change often is. When information is fragmented, perception fills the gaps. This is where calm analysis becomes valuable. Separating observation from assumption, distinguishing probability from certainty, recognizing that complexity does not imply intention. Natural systems do not operate with motive. They operate through physics, chemistry, and time. Human systems, however, respond emotionally. They attach meaning. They assign blame. They search for control. Acknowledging this tendency does not invalidate belief or curiosity. It places them within a broader framework of understanding. Curiosity leads to learning. Fear leads to fixation. The difference matters. As environmental and technological systems evolve, the challenge is not simply to predict outcomes. It is to maintain clarity of thought, to remain grounded in evidence while accepting uncertainty, to resist oversimplification when complexity is unavoidable. Throughout history, societies that navigated change successfully shared common traits. They valued information. They encouraged adaptation. They avoided rigid narratives that collapsed under pressure. As we continue, we turn toward the long view, examining how perspective, patience, and time reshape understanding. This exploration continues. To understand large-scale change, perspective matters. Human time is measured in years and generations. Planetary time is measured in thousands, tens of thousands, and millions of years. What appears sudden within a human lifetime may be gradual within Earth's systems. Magnetic shifts, climate transitions, tectonic movement, and solar cycles unfold across immense spans of time. They do not follow human schedules. They do not respond to political boundaries or economic systems. They operate according to physical laws that predate civilization. This difference in timescale creates tension. Events that feel urgent to humanity may be minor fluctuations within planetary history. At the same time, slow changes can still produce meaningful consequences for complex societies. Modern civilization is uniquely interconnected. Infrastructure depends on stability. Supply chains assume predictability. Technology amplifies both efficiency and vulnerability. This does not mean collapse is inevitable. It means adaptation becomes increasingly important. Throughout history, resilience has favored societies that adjusted rather than resisted change. Adaptation does not require certainty, it requires flexibility. It requires planning without panic. It requires understanding risk without exaggeration. In the long view, Earth has remained habitable through countless transformations. Life has endured ice ages, magnetic reversals, asteroid impacts, and volcanic winters. Extinction events occurred, yet biodiversity recovered. Human civilization, however, is still young by planetary standards. Its challenge is not survival of life, but continuity of systems. Food distribution, energy production, communication networks, social cohesion. These systems depend not on stopping change, but managing it. Preparedness in this context is not fear-driven. It is awareness-driven. It involves strengthening infrastructure, protecting knowledge, reducing unnecessary fragility. Resilience is built quietly, often invisibly. It emerges from redundancy, decentralization, and foresight. The long view encourages patience. It tempers urgency with context. It replaces alarm with understanding. Change is neither inherently destructive nor inherently benevolent. It is neutral. Its impact depends on response. As this exploration continues, we begin to shift from analysis toward synthesis, from observing patterns to considering how humanity fits within them, from asking what may happen to asking how societies respond. The story of change is not a single event. It is an ongoing process, and perspective shapes every chapter. This exploration continues. When observing complex systems, signals matter more than predictions. Signals are measurable, they are observable, they exist independently of interpretation. Conclusions, by contrast, are shaped by perspective, belief, and expectation. Throughout this exploration, we have examined signals, the movement of Earth's magnetic poles, the behavior of solar activity, the dependence of modern infrastructure on environmental stability, the growing emphasis on resilience and preparedness. Each signal stands on its own. None require speculation to exist. Together, they form a landscape of change that invites attention rather than alarm. The mistake often made is assuming that signals demand immediate conclusions, that observation must lead to certainty. In reality, uncertainty is a natural state when dealing with large-scale systems. Science advances by narrowing uncertainty, not eliminating it. Patterns become clearer over time. Data accumulates. Understanding evolves. This process is slow by design. Human perception, however, favors immediacy. It seeks definitive answers. It gravitates toward narratives that simplify complexity. Yet simplification can obscure reality rather than reveal it. The most reliable approach is balance, acknowledging signals without exaggeration, remaining curious without becoming reactive, preparing without assuming inevitability. This mindset mirrors the scientific method itself. Observe, measure, reevaluate, adjust. In this way, preparation becomes adaptive rather than defensive. Awareness replaces fear. Resilience replaces panic. Throughout history, civilizations that endured periods of transformation shared one trait: they remained flexible. They did not lock themselves into rigid explanations. They allowed understanding to evolve as conditions changed. The present moment is no different. Technological systems grow more complex. Environmental systems continue to shift. Human systems respond unevenly. These dynamics do not point toward a single outcome. They point toward ongoing adjustment. Signals guide attention. They do not dictate destiny. By learning to distinguish observation from assumption, humanity improves its capacity to respond thoughtfully. As we move toward the final stage of this exploration, we turn inward, examining how awareness itself shapes response. This exploration continues. When observing complex systems, signals matter more than certainty. Signals are patterns. They are not predictions. They do not announce outcomes. They indicate movement. Across natural systems, change is often preceded by subtle indicators rather than dramatic events. Magnetic drift, increased solar activity, fluctuations in climate behavior, shifts in animal migration, changes in long-term geological measurements. Individually, these signals may appear insignificant. Together, they form context. Science does not interpret signals as warnings or prophecies. It treats them as data. Measurements are gathered, trends are tracked, models are refined. Uncertainty is acknowledged. This process is slow by design. It favors accuracy over urgency. Public attention, however, often works in reverse. Signals are amplified. Narratives form quickly. Fear can emerge before understanding. This gap between observation and interpretation is where confusion often begins. In complex systems, causation is rarely singular. Solar activity does not act alone. Magnetic behavior does not operate in isolation. Climate, geology, biology, and cosmic influences interact continuously. Separating correlation from causation requires patience. It requires restraint. And it requires resisting the urge to force conclusions. Throughout history, societies have attempted to explain change through stories. Some stories provided meaning. Others provided comfort. Some reflected observation. Others reflected anxiety. Modern information systems accelerate this process. Ideas spread faster than analysis. Speculation can outpace verification. This does not invalidate questions. It reinforces the need for discipline in asking them. Signals do not demand belief. They invite attention. They encourage monitoring rather than reaction. They suggest preparation without assumption. In scientific frameworks, preparedness does not mean expecting a specific event. It means increasing resilience across multiple scenarios, strengthening infrastructure, protecting communication systems, preserving knowledge, reducing single points of failure. These measures are beneficial regardless of outcome. They do not rely on certainty, they rely on adaptability. In this sense, preparedness is not pessimistic, it is practical. As this exploration continues, the focus shifts away from answers and toward awareness, toward understanding how humanity interprets change, how narratives form around uncertainty, and how societies choose between fear-driven reaction and measured response. Signals remain signals. They do not declare destiny. They invite observation. They invite reflection. And they remind us that complexity rarely offers simple conclusions. This exploration continues. When observing complex systems, signals matter more than certainty. Signals are patterns. They are not predictions. They do not announce outcomes. They indicate movement. Across natural systems, change is often preceded by subtle indicators rather than dramatic events. Magnetic drift, increased solar activity, fluctuations in climate behavior, shifts in animal migration, changes in long-term geological measurements. Individually, these signals may appear insignificant. Together, they form context. Science does not interpret signals as warnings or prophecies. It treats them as data. Measurements are gathered, trends are tracked, models are refined. Uncertainty is acknowledged. This process is slow by design. It favors accuracy over urgency. Public attention, however, often works in reverse. Signals are amplified. Narratives form quickly. Fear can emerge before understanding. This gap between observation and interpretation is where confusion often begins. In complex systems, causation is rarely singular. Solar activity does not act alone. Magnetic behavior does not operate in isolation. Climate, geology, biology, and cosmic influences interact continuously. Separating correlation from causation requires patience. It requires restraint. And it requires resisting the urge to force conclusions. Throughout history, societies have attempted to explain change through stories. Some stories provided meaning. Others provided comfort. Some reflected observation. Others reflected anxiety. Modern information systems accelerate this process. Ideas spread faster than analysis. Speculation can outpace verification. This does not invalidate questions. It reinforces the need for discipline in asking them. Signals do not demand belief. They invite attention. They encourage monitoring rather than reaction. They suggest preparation without assumption. In scientific frameworks, preparedness does not mean expecting a specific event. It means increasing resilience across multiple scenarios, strengthening infrastructure, protecting communication systems, preserving knowledge, reducing single points of failure. These measures are beneficial regardless of outcome. They do not rely on certainty, they rely on adaptability. In this sense, preparedness is not pessimistic, it is practical. As this exploration continues, the focus shifts away from answers and toward awareness, toward understanding how humanity interprets change, how narratives form around uncertainty, and how societies choose between fear-driven reaction and measured response. Signals remain signals. They do not declare destiny. They invite observation. They invite reflection. And they remind us that complexity rarely offers simple conclusions. This exploration continues. Preparation does not always announce itself. Often, it happens quietly, away from headlines, away from urgency. In complex systems, the most effective responses are rarely dramatic. They are gradual, they are practical, they focus on reducing vulnerability rather than predicting outcomes. Throughout history, societies that endured periods of change shared common traits. They invested in knowledge. They preserved systems of communication. They diversified resources. They avoided dependence on single points of failure. Quiet preparation does not assume catastrophe. It acknowledges uncertainty. It strengthens resilience without declaring expectation. In modern contexts, this may appear as infrastructure reinforcement, redundant energy systems, distributed data storage, food security planning, emergency communication networks. These actions do not require belief in a specific event. They are beneficial across a wide range of scenarios. Preparedness, in this sense, is not fear-based. It is responsibility-based. It reflects awareness rather than alarm. On an individual level, quiet preparation can be even simpler. Understanding systems, staying informed without becoming overwhelmed, maintaining adaptability, developing skills that remain useful under changing conditions. History shows that adaptation favors flexibility over rigidity. Societies that insist on permanence often struggle during transition. Those that allow systems to evolve endure longer. This does not imply inevitability. It implies choice. Choice in how knowledge is preserved. Choice in how resources are managed. Choice in how uncertainty is faced. In moments of perceived instability, silence can be more powerful than noise. Reflection can be more effective than reaction. Calm observation allows space for understanding. Quiet preparation does not demand attention. It does not require urgency. It simply exists. As this exploration continues, the focus shifts away from what may happen and toward how humanity responds. Not through prediction, but through readiness. Not through fear, but through awareness. This exploration continues. Preparation does not always announce itself. Often, it happens quietly, away from headlines, away from urgency. In complex systems, the most effective responses are rarely dramatic. They are gradual. They are practical. They focus on reducing vulnerability rather than predicting outcomes. Throughout history, societies that endured periods of change shared common traits. They invested in knowledge. They preserved systems of communication. They diversified resources. They avoided dependence on single points of failure. Quiet preparation does not assume catastrophe. It acknowledges uncertainty. It strengthens resilience without declaring expectation. In modern contexts, this may appear as infrastructure reinforcement, redundant energy systems, distributed data storage, food security planning, emergency communication networks. These actions do not require belief in a specific event. They are beneficial across a wide range of scenarios. Preparedness, in this sense, is not fear-based. It is responsibility-based. It reflects awareness rather than alarm. On an individual level, quiet preparation can be even simpler. Understanding systems, staying informed without becoming overwhelmed, maintaining adaptability, developing skills that remain useful under changing conditions. History shows that adaptation favors flexibility over rigidity. Societies that insist on permanence often struggle during transition. Those that allow systems to evolve endure longer. This does not imply inevitability. It implies choice. choice in how knowledge is preserved, choice in how resources are managed, choice in how uncertainty is faced. In moments of perceived instability, silence can be more powerful than noise. Reflection can be more effective than reaction. Calm observation allows space for understanding. Quiet preparation does not demand attention. It does not require urgency. It simply exists. As this exploration continues, the focus shifts away from what may happen and toward how humanity responds. Not through prediction, but through readiness. Not through fear, but through awareness. This exploration continues. As this exploration reaches its quiet conclusion, stillness becomes important. Complex systems do not resolve themselves in moments. They unfold, they adjust, they continue. Earth's story did not begin with humanity, and it does not end with uncertainty. Change has always been present. Cycles have always existed. The planet does not rush. It does not announce transitions. It simply moves forward. For humanity, understanding emerges slowly. Knowledge accumulates. Perspective deepens. Questions evolve. What once felt unknown becomes familiar. What once felt overwhelming becomes manageable. Stillness allows this process to occur. It creates space between information and reaction, between observation and interpretation. In that space, clarity grows, not through certainty, but through awareness. Throughout history, survival has favored those who remained attentive rather than alarmed, those who adapted rather than resisted, those who observed patterns instead of demanding answers. Preparedness, at its core, is not anticipation of disaster. It is alignment with reality. It is the recognition that change is constant, and flexibility is strength. As societies evolve, knowledge persists. As systems shift, life continues. The future is not a single event. It is an accumulation of moments, decisions, responses, adaptations. This exploration does not seek conclusions. It invites reflection. It encourages patience. It values understanding over urgency. As you continue listening, allow the ideas to settle without demand. There is no requirement to resolve them, no need to decide. Only awareness remains. Change continues. Life continues. The story continues. And understanding grows quietly over time.